Hey guys, welcome back to my channel and I hope that each one of you are healthy and safe. Today I'm here to talk about one of the most widely used statistical measure, that is correlation. So in this video I'll be covering only on the theoretical aspects of correlation, and in my next video I'll be covering on the special correlation cases, and also on how to use SPSS to compute correlation. That will be covered in my next session. So in this session, I'll be covering on the brief introduction of correlation, the significance of correlation, the degrees of correlation, the types of correlation, and also the various methods used to study correlation, along with their merits and limitations. So now let us look them one by one. Coming to the intro, correlation is a statistical measure to determine the association of relationships between two or more variables, in which the changes in the values of one variable is followed by the changes in the another variable. So in case of educational research, we used to study correlation. For example, in case of students, when we study students, then we study the relationship between academic achievement versus learning style, motivation, home environment. So these are some of the variables. And in case of teacher, we also study the relationship between the job satisfaction and the salary package, and also the working hours. So these are some of the areas where we used to study where we use correlation. And then the next is the measure of correlation is called coefficient of correlation, and it is denoted by small r or rho. So small r denotes Pearson correlation, or also known as product moment correlation coefficient, and rho is used to denote Spearman correlation, or also known as rank correlation coefficient. So the values of correlation ranges from +1 to -1. Now coming to the significance of correlation, it is used to study the relationship between the variables, and it helps in measuring the degrees of the relationship. Degrees of relationship means the extent to which the two variables are related to each other. And next is it also used to study the direction between the variables, that is whether it is directly proportional or inversely proportional. And next, it helps to test the significance of the relationship between the variables. And next is it forms as the basis for calculating other more rigorous statistical calculations, such as regression. And it helps to determine if a relationship is significant enough to permit valid predictions. And the effects of correlation reduces the range of uncertainty of our prediction. So now coming to the degrees of correlation, these are the ranges, degrees. And then when we have both positive and negative. So when the values are in the form of negative, we can say there is a negative correlation, and when it's in the form of positive, we can say that there is a positive correlation. So when our computed correlation value is +1, we can say that there exists perfect positive correlation between the two variables. And when our obtained correlation value is -1, we can say that there exists perfect negative correlation between the two variables. Similarly, if the values ranges from 0.91 to 0.99, we can say that there exists a very high correlation between the two variables. Similarly, if it's positive, you can say positive. If it's negative, you can say negative. Similarly, for if the values ranges from 0.71 to 0.9, we can say that there exists a high or strong correlation between the two variables. Similarly, you can also interpret your result, which has been written here: moderate correlation or low correlation. So these are the ranges for this. So if the value obtained is 0, we can say that there is no correlation, or there is zero correlation. So this has been taken from the Mangal book of statistics. And various book, there is a slight variation of this range. So but more or less it's all the same. And now moving on to the next, the types of correlation. So based on the degrees of correlation, we have positive correlation, negative correlation, or no correlation. So we are not including the no correlation since it's 0. So next is based on the number of variables, we have simple correlation, partial correlation, and multiple correlation. And based on the linearity, we have linear correlation and non-linear correlation. So let us look them one by one in a very brief manner. So based on the degrees of correlation, we have positive correlation and negative correlation. So correlation is said to be positive when the values of two variables moves in the same direction. It means when it is directly proportional to each other. That is when the increase in one variable, there is an increase in the another variable, and when with the decrease in one variable there is a decrease in the another variable. So for example, height and weight, this is directly proportional to each other. So with the increase in height there is an increase in weight, with the decrease in height there is a decrease in weight. So these are directly proportional, and this is known as positive correlation. So coming to the negative correlation, correlation is said to be negative when the values of two variables moves in the opposite direction. That means it is inversely proportional to each other. So when the increase in one variable, there is a decrease in the another variable. And when there is a decrease in one variable, there is an increase in another variable. So this is one example, vaccination and illness. So when there is an increase in vaccination, we can see that there is a decrease in the illness. And when there is a decrease in the vaccination, there is an increase in the illness. So this is one very good example of negative correlation. Moving on to the next, based on the number of variables, we have simple correlation, partial correlation, and multiple correlation. So we call it simple correlation when we study the correlation between two variables. Say, for example, the relationship between self-confidence and interpersonal skills. And next, partial correlation. So when we study the correlation between two variables while controlling one or more intervening variables, then we can say that it's a kind of partial correlation. Say, for example, studying the relationship between academic achievement and motivation of the child by keeping the intervening variables such as home environment as a constant. So in that case, we call this as a partial correlation. So multiple correlation is when we study the correlation between three or more variables. Say, for example, the study of the correlation between academic achievement, learning style, motivation, and the time span, and so forth. So coming to the next, based on linearity, we have non-linear and linear. So linear is when the amount of change in one variable tends to bear a constant ratio to the amount of change in another variable. So the best way to understand this is in the graphical representation. So the graphical representation of a linear correlation will be in the form of a straight line. So the next, coming to the non-linear correlation, when the amount of change in one variable does not bear a constant ratio to the amount of change in the another variable, then we call that it is a kind of non-linear correlation. So the best way to understand is the graphical representation of non-linear correlation will be in the form of a curve instead of a straight line. So this is how it is being represented, linear in the form of straight line and non-linear in the form of curve. So next, coming to the next, methods of studying correlation. So we have graphical method and we have algebraic method. So graphical method we can study using scatter plot, and algebraic method we use Pearson's coefficient of correlation and Spearman-Frank correlation of coefficient. So let us look them one by one. So graphical method of, that is scatter plot, we have this kind of these are the types that we can obtain using scatter plot. So for strong positive correlation you can see such type of pattern, and similarly for weak positive correlation you can see such type of pattern. Similarly, when there is no correlation, you can see that all the values are scattered all over the plot, scatter plot. So there is no relationship between any of these values. So now let us look on the merit and demerits of using graphical methods. So the merit is it is very simple to use and understand. And next is it doesn't need any mathematical calculations. And next is it is usually used as the first step to understand the correlation between the variables. And when it comes to demerits, the first and foremost demerits is that it cannot study the degrees of correlation between the variables. It can only study the relationship and not the degrees, how far the relationship is there exists. So it cannot study the degree. And now moving on to the next, Pearson's coefficient of correlation. The Pearson's coefficient of correlation, also known as product moment correlation coefficient, is a measure of the strength of a linear association between the two variables. So here take a very note on this term, the linear association. So Pearson's coefficient of correlation study the linear association. It does not study the non-linear relationship. It only studies the linear. That means when it comes to a graphical representation, you can see a straight line. So it is a type of parametric test, and thus it follows the assumptions of a parametric test. So it is denoted by R or Rxy, where xy is the two variables that is involved or that is being studied. And the values of R ranges from +1 to -1. This will be the same for all kind of correlation. And we can calculate Pearson by using assume mean or actual mean. So when we use actual mean, this is the formula. And when we use assume mean, this is the formula for calculating Carl Pearson's coefficient of correlation. So now moving on to the assumptions of product moment correlation. So since it's a parametric test, so it follows all the assumptions of a parametric test. That is, the first one is assumptions of normality of distribution. It means the distribution in two variables being compared should be fairly symmetrical or in the form of a normal curve. So next is assumptions of linearity. It means that the relationship between the two variables should be in a linear fashion. That means it's a straight line. And next is assumption of continuity of variables. So the two variables under study should be in continuous in nature. That is, it can be measured in either interval or ratio scale. And the next is assumptions of homoscedasticity. It means it is an assumption of equal or similar variances in different groups being compared. That is, the standard deviation of the scores in different columns and rows should be equal and fairly homogeneous. So these are the assumptions of product moment correlation or a parametric test. And now coming to the merits and limitation of product moment correlation coefficient. Uh, in the merit we can see that it is the most popular statistical method used to measure the relationship between the variables. So it is very widely used. And next is it helps in studying the degrees of correlation. That means how to what extent the relationship exists between the two variables, and also the direction means whether it's directly proportional or inversely proportional. And next is it can be used for both group as well as ungrouped data. The next is interval and ratio scales are used in this product moment correlation coefficient. Therefore, the results obtained is more precise and exact. And limitation in the next is limitation. So we can see that it is affected by extreme values. Since we can see that it uses both group and ungrouped data, and the extreme values affects the results. So next is it is tedious and time consuming. And next is it always assumes a linear relationship among the variables. So this is one of the limitation, because there can be cases where there is non-linear relationship between the variables also. So in that case we cannot use product moment correlation. So now coming to this next one is Spearman's rank correlation coefficient. It is also known as rank correlation coefficient, and it considers values in the form of a rank. So it is denoted by rho, and it is a type of non-parametric test. So the formula is this one, the formula for Spearman rank correlation coefficient. So you can get the steps. I have not included the steps in this session. You can get the steps in any kind of statistical book. So P means the rho means Spearman rank correlation coefficient, and D means the differences in the ranks between the pair items, and n means the number of paired observations, and d summation d square means sum of squares of the differences of the two ranks. And now let us look on the merits and limitations of rank correlation coefficient. So the merits is it is easy to compute and understand and not affected by extreme values. And the next is uh, it is highly useful for computing the relationship of data that are in the form of a qualitative aspect. So for example, honesty and satisfaction. So when our data are in the form of qualitative in nature, then we can use the rank correlation. And next is it is the only method that can be used when the ranks of the items are available. And when it comes to limitation, we can see that it cannot be used for group frequency. So it can be used only on ungrouped data. And next is it is difficult since it is used for ungrouped data. So when the n value, the frequency is more than 30, so it becomes very tedious and time consuming to calculate. And the next is the results obtained is not as precise as that obtained from Pearson product moment correlation coefficient, because in Pearson we can see that they use ratio or interval scale, but in case of rank correlation we don't use such kind of high quality scales, so the results obtained are not as precise. So these are the things that will be covered in this session. So I hope that you have enjoyed this session, and thank you all for listening. And if you like my contents, then please do support me by subscribing to my channel. And lastly, take care and see you again in my next video.